Hello class, this is a continuation of combinations part 2. In this video we'll be looking at some examples of what a combination is and how we would apply their calculations. So to reiterate, a combination is an unordered arrangement. So from a total of n objects, the number of unordered arrangements of length r can be calculated as n choose r equaling n factorial divided by n minus r factorial and further dividing by r factorial. You can find the button for it right here. There it is, NCR. And I'll demonstrate to you how you might calculate this. Now from this point forward, I'm going to be using this notation for it, and we pronounce this as n choose r. N choose r. So let's do it right here. A bag contains 6 colored discs, 2 red, 2 green, and 2 blue. If 3 discs are taken out of the bag, how many ways can this happen? Now to really demonstrate that this is an unordered an unordered arrangement, let's just simulate a few here. Red, red, green. So that's one possible way, but it could very well be red, green, red. Can you see how the order in which the red and the green come out, it doesn't matter. So this arrangement is the exact same as this arrangement. So this is an example of an unordered arrangement. To calculate this, we do the following. So there are 6 to choose from, and we only have 3 that we want to choose. So 6 choose 3. Simple as that. And how we would calculate it is 6 choose, oh, wrong symbol, it's different on this calculator. Let me try that again. 6, oh, there it is for my one, that's under the division symbol. 6 choose, you'll have that C symbol. 6 choose 3, 20. So there are 20 different ways you could choose 3 discs from 6 different colored discs. Simple as that. From a total of 20 players, 5 are to be randomly selected to form a team. How many ways can the team be formed? Once again, for this one, let's say we have 20 different people. Oh, let's actually just take a small sample of these. Let's say we have a team of A, B, C, D, E. And these 5 people come from the 20. But if we choose them in a different order, A, C, D, B, E, this team is the exact same as this team. So as you can see, just by picking them, there's no order to be found. If the question, however, stated that, let's say the first person chosen is the captain, the second person chosen is the vice captain, and so on. In that instance, because they're saying that the first position is captain, the second position is vice captain, in this example that I'm stating, order does matter. But just as the question here is being stated, because it's just to form a team, order does not matter. So, because order doesn't matter, we simply take the 20 total, and we're choosing 5. 20 choose 5. We can calculate that once again here. 20 choose 5. 15,504. You often don't need to do this because sometimes the answers are enormously large, and it's fine just to leave it in this choose notation. let's go. Here's a little bit more of a tricky question. You can pause the video and give this a go yourself. So a coach needs to form a team of 5 to represent their school. The coach can choose from his class of 8 seniors and 5 juniors. How many different teams can be formed if no restrictions are made? Now remember, because they're just making a team of 5, it hasn't stated whether the positions of those teams matter. So just as in this selection, the order doesn't matter, that'll be the same for this one. So for this, we just need to figure out how many total objects are there. Well, there's 8 and 5, so there are 13 total objects to pick from. And we want to make a selection of 5, or choose 5 of them. So that's 13, choose 5. Calculating it here, 13, choose 5. 1, 2, 8, 7. Here we go. In the exact same scenario now, this time there must be exactly 3 seniors. Okay, this gets a little bit tricky now. So if there has to be 3 seniors, let's focus in on that restriction first. Well, how many seniors does the coach have to pick from? Well, as stated here in the question, there are 8. Let's focus on that first. So there are 8, choose 3. We've picked just the seniors. This is similar to how we did this. Take a look. How many ways can these 3 be filled by seniors? There are 8 in the first one, 7 in the second one, and 6 in the last position. But because it's an unordered selection, we need to divide this by the number of ways we can switch them around. So this first 3 is like this. Oops, sorry, that's 6. Now this next 2, well, they have to be filled with the remaining juniors, because it says exactly 3 seniors. So these next 2 positions must be filled with the juniors. Well, there are 5 juniors to pick from, and there are only 2 positions left. So the total number is actually calculated as 8 choose 3 times 5 choose 2. And whatever that is there. You can type it in your calculator. I'll do it here. You can quickly fast forward this. 8, choose 3. Let's put that in the bracket. Times 5, choose 2. Should be a very large number here. 500, oh, not as big as I thought. There are 560 teams where there are exactly 3 seniors. One last one. There must be more senior students than juniors. So there must be more senior students than juniors. So let's think about how many ways we can do this. We could have 3 seniors and 2 juniors. We could have 4 seniors and 1 junior. Or we could just have a team of 5 seniors. Notice how I worded that. 3 seniors and 2 juniors, or 4 seniors and 1 junior, or 5 seniors. Similar to probability, whenever we see this word or, it's just another way of adding the different options. So for this, we just need to calculate these 2. So we already have the first one. It's 8 choose 3 times 5 choose 2. That's exactly 3 seniors. Plus 4 seniors. Well, there were 8 seniors to choose from. So that's 8 choose 4. So from the 8 seniors, we're going to choose 4 of them. Times from the 5 juniors, we're going to choose 1 of them. So that's 4 seniors and 1 junior. And one last calculation. It's just 5 senior students. Well, that's going to be 8 seniors to choose from and 5 chooses. So let's just calculate this. We know what this one is. That's 560 plus. Let's quickly calculate that middle one here, this one. So we have 8 choose 4 times 5 choose 1. That's 350 for this one. And 8 choose 5. 8 choose 5. It's 56. Adding all of these together, that's, just try to do it with my head, that's 406. That's 966 different ways, so that there are more seniors than there are juniors. So I hope that it's these examples have made it clear for you on how to identify when something is a permutation and when something is a combination. Hope to see you in the next video. Best of luck.